Hello guys, welcome back. In this video, let's see another interesting service, that is Kubernetes services, EKS. So what is this? Before going to learn about EKS, that is Elastic Kubernetes service, let's see about what is Kubernetes, right? Yeah. So what is this Kuber? What is this Kubernetes? Kubernetes is nothing but it will manage containers for you. It's a open source system. It will manage containers for you. Kubernetes is nothing but it's a open source. It will manage containers. For whom? For you. It's a open source system. Okay. Why we need Kubernetes, sir? We have EC2. Why we need to use this Kubernetes? We have even ECS, we have even batch. Then why do we use this Kubernetes? Why do we go for this EKS? So Kubernetes will provide you rollback and roll updates. What it will provide you? It will provide you roll updates and rollback. So what is roll update and what is rollback? Let us see about it. Roll update and rollback is nothing but whenever if you are creating your new, if you are uploading your new version of your application, then what happens? Generally, if you use EC2, then the current servers will be deleted and again new servers will be launched. So during that time, does EC2 leads to downtime? Yes, EC2 leads to downtime. Whenever you just installed another update, that is nothing but whenever you want to provide the latest version of your application, then while launching your EC2 instances and deleting your EC2 instances, they may provide you what? Downtime. So how can you avoid this downtime? You can avoid this downtime by simply role updating and roll backing. That is nothing but you are just replacing the existing containers. Since EKS is a since Kubernetes will manage containers, your applications will be where? Inside your containers, right? Yeah, your applications will be present inside your containers only. So whenever you want to update your version of your application, then what happens is it just rollbacks. That is nothing but it just rollbacks and updates your current application container. Nothing but it will just replace the current container. So this Kubernetes will just replace the current container and provide you no downtime. So if a user requests, then whatever the past version, then that will respond to your request initially. If you roll back and update your version of your application, then what happens is during the application replacement time, it will provide the response by previous version of your application only. After updating, after replacing, it will provide you the response of the current application. In this way, it provides you the response. So there is another way, there is another time also EC2 even provides you downtime while while running and whenever a region go down, then this may provides you downtime. Even you can manage this downtime by using replication. By using replication in Kubernetes, you can able to manage this downtime as well. And not only these two, there are many multiple advantages whenever you use this Kubernetes. So now let us see why do we need to go for this Kubernetes instead of container. ECS is a containerized service and batch is also one of the containerized service. Why do we go for this Kubernetes? If you want to run a batch of workloads, then you choose this AWS batch. If you want to run a server applications or web applications, then you need to choose ECS. If you want to run a lot of servers, if you want to run a lot of servers for your containers, then you need to choose this EKS. If you want to run a lot of containers, that is from tens to millions. If you want to run lot of containers, that is 10 containers to millions of containers, then you need to choose this EKS. So by using this EKS, by using Kubernetes, you can able to manage and control whatever the containers you have, millions of containers. It acts as a pilot to your ship to manage all your containers which is present in the ship. So Kubernetes is what? It will act as pilot to your ship and it will manage all your containers. So even we can call this Kubernetes as K8s because what are the total number of elements that are present in between K and S is totally 8. So we call it as K8s. Okay. You're telling EKS is providing role updates and role backings by using replicas. Then how the architecture, how the ECS cluster architecture will be. So mainly let us see the cluster architecture, how the cluster architecture will be. So let's say this is my ECS cluster. This is my ECS cluster where it has mainly two layers. It has mainly two layers. What is this? It's a ECS cluster, right? Yeah. So it's a EKS, Elastic Container Service, right? Elastic Kubernetes Service. So it's a cluster of EKS. So in this cluster of EKS, mainly we have two planes. Mainly we have two sessions. First session contains control plane. First session contains control plane and second session contains data plane. What is that? Data plane. So how the architecture of EKS cluster will be? It contains that architecture contains two planes. First one is control plane and second part is data plane. What does this control plane consist of? This control plane consists of master nodes. What? Master nodes. This control plane contains master nodes, whereas this data plane contain worker nodes. What? Worker nodes, right? Yeah. So this master plane contains master nodes and this data plane contains worker nodes. So let's see how request get response through this EKS cluster architecture. Through this EKS cluster architecture, how a request will get the response. Let's see a client is requesting. Let's see a client send a request. That request first received to where? It first reaches to control plane and then from master nodes the request reaches to where? Data plane. So here what nodes we have? We have worker nodes. So these worker nodes can process and provide the request back to the client. So this is the top level view of your EKS cluster. Let's move on in depth into it. So I'd like to provide you one more example so that you can able to understand this very better. Let's say client is sitting in a chair. Client is sitting in a chair. He want to listen a music which was produced by the musician, which is where musician is present in the data plane. Now, who is this master, sir? These are nothing but they control the which musician will play which amount of time and which musician play how much frequency. Everything related to worker nodes will be maintained by the master nodes. So based on the musicians present in the data plane, the professional musicians which are present in control plane will control the data plane musicians, and the client who is present at the seat can able to listen the beautiful voice, beautiful music which is coming from the workers nodes, right? Yeah. So in normal scenario, before EKS comes into picture, we need to create our master nodes as well as our worker nodes as well. So this whole architecture of Kubernetes, this is the architecture of actually Kubernetes architecture, Kubernetes cluster architecture. So this is actually Kubernetes cluster architecture. So how the Kubernetes cluster will work is it contains two planes, control plane, master plane. Master plane contains nodes, that is control plane contains master nodes, and data plane contains worker nodes. These master nodes will control the worker nodes and provide the response based on the request. Okay. So in order to provide this control plane and data plane, do I need to install my servers? Yes, of course. So for the master plane, I need to install some servers, and for the data plane, I need to install some servers here. So let's say I have installed some servers in the master nodes, master plane, that is control plane. In control plane, I have installed some servers. So now what happens? So let's say I installed some servers. This is one server and this is one server. Like that, I have installed multiple servers in it. In similar way, I have installed multiple servers in it in the data plane also for workers. Now to maintain this control plane, what are the issues that what are the issues that this master nodes, what are the issues that we are facing while maintaining this control plane? While maintaining this control plane, we are facing the issues like, so sometimes it may happens that scheduler not work. Scheduler does not work sometimes. Scheduler do not work sometimes. Sometimes the scheduler will not work, and sometimes the certificates which are provided under these instances will get expired. Certificates will get expires sometimes, and sometimes the etcd will crash. Etcd will crashes whenever you're maintaining this master nodes. Then you may encounter mostly these issues, that is scheduler will not work, or else sometimes certificates will expire, or etcd will crash, and API server even goes down. API server even goes down. So it becomes, actually this architecture is maintained by DevOps engineers. So this is becoming a lot of problem to them. So to maintain this whole, these are only few issues I'm showing you. There are multiple issues even there. So to maintain these multiple issues, what happens? The DevOps engineers got a lot of frustrated and they are even not solved sometimes. So it leads to your client's response negative. That means these servers are unable to respond to your client. So since you're facing a lot of issues, now what happens is superhero comes. Who is the superhero? Cloud. Cloud comes. Now cloud comes and take these issues as opportunity and provide you the Kubernetes services, and they provide you the Kubernetes services by managing all these issues. What are the issues that you have? Let's say these are the issues, right? These all are issues. These all issues are overcome by using cloud provider. By using the cloud platform, these all issues will be overcome, right? Yeah. So now what are the cloud providers, top cloud providers we have, and what are the services they are providing for these Kubernetes services. For to overcome this Kubernetes issue, AWS will provide you EKS, that we are going to discuss. And let us see about the just what are the service names that are provided by other cloud service providers as well, so that you can able to understand those as well in future if you have a need to use that cloud service provider. So GCP provides you Google Kubernetes engine for overcome this Kubernetes cluster architecture. So, and this cloud providers will provide all the control plane. All the control plane will be provided by whom? Cloud providers. Who is providing, who is taken care of all the issues while maintaining the control plane is taken care? Cloud provider is taking care of all the issues or maintaining and providing the control plane. The master nodes, everything will be created by whom? Cloud providers. AWS provides you the service in the form of Google Kubernetes engine, whereas Azure provides you in the form of Azure Kubernetes engine, where Azure Kubernetes services. AWS overcomes this problem by using Elastic Kubernetes services. Now, in order to avoid managing control plane, AWS provides you which service? Elastic Kubernetes service for us. So control plane and what are the master nodes that we have? Do we need to control those? No. Then do we need to manage those? No. So who will manage them for us? AWS. By using which service? By using EKS service, right? Yes. So now still we have a burden to maintain this data plane. So what does this data plane contains? This data plane contains worker nodes, right? Yes. So we can maintain. So if you are expecting to have whole control over your infrastructure, if you want to expect the whole control over your infrastructure, which is present under your data plane or worker nodes, then what is the service you need to choose? Then at that case, at that particular scenario, since you are expecting the whole control over your infrastructure, so you choose EC2 clusters, EC2 instances in this cluster. So then you can have a full control over your infrastructure of your resources. So let's say I don't want to even manage this. I don't want to even manage this data plane. I just want to manage my application and focus on my application to provide some more services to my client. Then is there any service in AWS where it can manage even my data plane also? Yes, there is a service that is called AWS Fargate. What is that? AWS Fargate. By using this Fargate, you don't even need to maintain. These. You don't even need to maintain the underlying infrastructure. So by using these ways, you can able to control whole Kubernetes cluster architecture in AWS by using EKS. By using EKS service, you can able to control whole Kubernetes cluster architecture in EKS. So by default, EKS will provide you control plane. That means you can able to manage your master nodes, and to manage these data plane, you can, if you want control, then you can choose EC2 instances. If you don't want to take risk or control the management of whole infrastructure, then you need to choose AWS Fargate. So if you choose this Fargate, then there is a high probability of your architecture for high availability, and your architecture is even highly scalable. So since you are having high availability and scalability, can I say the architecture formed by EKS and whatever the clusters or else whatever the nodes, worker nodes or data plane formed by Fargate will provide me a robust application, robust architecture. Yes. So it will provide you a robust architecture. So if you use such type of robust architecture, then what you need to focus on, you have a lot of time to focus on your application in this case. So EKS, when do you use this EKS? Since you're managing tens and millions of your applications, you use this EKS whenever you're having large scale applications, large scale production applications. So what do you prefer? You need to prefer this EKS. So when do you prefer this EKS? So whenever you're having large scale production application, you can use this EKS. So can I say EKS provides me deployment and scaling of my containerized applications? Yes. Since this EKS providing me accessibility to automatically deploy and scale my applications in the form of containers, I can say it's a best architecture for holding my millions of large scale applications. Okay. Let's say, let's see how to put my application in this data plane. So we are having data plane, right? Let's see how to put our application in this data plane. You can put your application, you can put and host your application in containers, where you're putting and hosting your application under containers. So let me erase this. Yeah. So where you're putting your application under, where you're putting your application under containers, where containers. So now let's have a question. Now let's have a question. Where you're putting your application, you're putting your application under containers. So now where these containers are present, where these containers are present, containers are present under pods. Where your containers present, your containers present under pods. So what is this pod, sir? It is nothing but your VM, virtual machine. Even you can say it's as instance. So we call an instance as a pod. So can you tell me a single instance can able to create only one container? No. So by using a single instance, you can able to create one or more containers, right? So one or more containers you can able to create in a single pod. In a single pod, you can able to create one or more containers. In a single container, can you host one application? Yes, you can host one application in a container. So in a pod, how many applications you can able to host? At least one, and at max, how many containers you can able to create in a pod? Those many applications you can able to host in a single pod, right? Yeah. So each pod has a IP address. Each pod has an IP address. So pod is nothing but instance only, right? Does instance having IP address? Yeah. So we can say each pod has its own IP address. Each pod has its own IP address. So it is accessible. So can I say by using this IP address, can I access this pod within this data plane? Yes, I can able to access this pod within this data plane. So, sir, you told us we are deploying our application in containers and these containers present in the pods. Then how can we create these pods inside this data plane or worker nodes? We can able to create these pods. We can able to configure these pods by using kubelets. What is that? Kubelets. How can you able to provide or configure these pods? By using kubelet, kubectl. By using the kubectl, you can able to configure your pods. So not only pods, I'm going to tell you about services. Those also even provided by using or configured by using this kubectl. So let's see, data plane present in where? You told each pod having a particular IP address, right? So, but you're told only within that data plane only we can able to access my pods. Why not outside? Since you are having an IP address, right? Why not outside? This IP address is acceptable only inside this data plane. Why only inside data plane, sir? Because your data plane is present inside private subnet. Where? Private subnet. Your data plane is present inside private subnet. So whatever the VPC you are having, in that VPC you are having public subnet and private subnet, right? Yeah. So since you need to host your applications, where you host your applications? Do you host your applications under public subnet or private subnet? We need to host our applications under private subnet only, not public subnet. So in order to host my applications under public subnet, where my applications are present under containers, where my containers are present, my containers are present under pods, where my pods are present, my pods are present under data plane. So we need to put our whole data plane under private subnet. In order to provide my application in private subnet, I need to put whole my data plane or worker nodes inside my private subnet. So I hope you understood why this is present in private subnet. So let's say I have a lot of users. Then this pod sufficient for me to host my application in container? No. So then I able to provide multiple pods, right? Yes. So by using what we can able to provide multiple pods. You can able to provide multiple pods by using server. What? By using service. By using service, you can able to provide multiple pods. So what is service, sir? Service is nothing but one or more pods. One or more pods. One or more pods combination, we call it as service. So what is service? Service is nothing but combination of one or more pods. So we can say a service can maintain multiple pods. Yes, a service can maintain multiple pods. Sir, you told whenever you create an application inside container, that container is present in pods. So pods having an IP address, we can able to access that IP address within this. That is, what do we say that? We say that accessing as cluster IP address. What is that IP address? That's nothing but a cluster IP address. So let's say, let's see what is node. What is node? At first, let's see what is node. Node is nothing but It is nothing but a physical instance. What is that? A physical instance. So on top of physical instance, can I say I'll create my virtual servers? Yes. On top of physical instance, I can create my virtual server. So can I say these pods as virtual servers? Yes. You can assume these pods as virtual servers, and you can assume nodes as your physical instances. So nodes are instances. That is, even in AWS, you can assume them as EC2 instances like that. And these pods can be on top of these nodes. So, okay. Now, in order to provide multiple services, in order to provide multiple pods for a single application, how can we able to provide? By using service. So how can I configure my service inside this data plane or inside this worker nodes? How can I configure my service, sir? You can able to configure same by using kubectl. By using kubectl only, you're configuring your service or else pods. So if anybody asks you how your cluster is communicating with Kubernetes by using these pods, and by using this kubectl, your cluster is communicating with what? Kubernetes. So you can able to configure your pods as well as services by using this kubectl. So actually you create a YAML file where in that you can provide all the configurations regarding these pods as well as services. So pods as well as services, and you just run this kubectl commands. So this whole thing will be created automatically from the command line interface. Even it is very easy to create from the command line interface this EKS whole architecture. So now let's move on with our topic. So let's say, sir, you told about services, right? So what are the type of services we have? So if I'd like to host, if I'd like to configure my service inside my data plane, so what are the different types of services that we have? So in services, we have three types. First one is cluster IP. So if you create this service, if you create this service, if you create this service for cluster IP, then it will provide you an IP address where that IP is acceptable, where that IP is accessible within this cluster only, right? Yes, within this cluster only you can able to access that IP. So but what I want to provide that IP address to my client, then only he can able to access my application, right? Yeah. So since my application is present in pods and my pods are present in my servers, if I provide a common server IP, then it will I need to provide that to my client to accept this service. How is it possible? And in these services, whenever you configuring your services, there is an option called you are configuring for cluster IP or node IP, or you have another option that is what? That is load balancer IP. Load balancer IP. So you have these three options. So while configuring, you have these three options. So let's say, in order to provide access to my client, I have created my load IP. I have created my service for load IP. So can this client able to access my whole service by using the load IP address? Yes. So client can able to access by using this load balancer IP address. But since we are providing access, to our services, that is nothing but providing access to all my pods, which is present in my services, right? Yes. So I'm also providing, what does it mean? I'm also providing all my containers access. That is nothing but all my applications access. That means this load balancer is facing to multiple resources. Yes. So since it is facing to multiple resources, AWS charges you a lot. AWS charges you a lot, right? Yeah. So how to overcome this? Service, by using the service, how can I provide a single IP? How to provide public access to this service? So we have again another way. This load balancer is one way, and another way is also there. So the another way is by using application load balancer. What is that? So you just create an application load balancer. You just create an application load balancer on top. And so in order to provide the access to what are the pods inside it, so you first need to create ingress. You first need to create ingress security. So in that ingress, you need to mention who can able to access your application. That is, you need to told what is the port, that is port number 80 if you want to access HTTP, and you need to specify the protocol, whether it is HTTP or which protocol. Like that, you need to provide a ingress security group inside this private subnet. Inside services, you need to provide this ingress traffic rule. Then in order to provide this to application load balancer, you need to configure again one thing, that is what? Ingress controller. ingress controller. You also need to provide this ingress controller. So what is the another way to access this? The another way to access this is providing an application load balancer, ingress controller, and ingress. So in the ingress, you need to mention which traffic is allowed, and under ingress controller, you need to provide what is the traffic is allowed, and you can able to connect by using the application load balancer and ingress by using this ingress controller. So how is it happening? By using certain protocols, that is LDAP, Octa, Auth. I have already discussed them under dictionary services. So if you need to focus more on that, then you can choose there. But it is recommended to focus on concept here. So in this way, this ingress controller provides the access to application load balancer via using this ingress. Now, how my client can able to access, how my client's request got the response? Let us see. Now client will request, that request will reach us to application load balancer at first, and then that reaches to ingress controller, then that reaches to ingress. Then from there that ingress security group will allow to your service, and from that service will allow the request to pods, and that pods allows the request to containers will allow request to applications. From the application the request will be accepted and response will be provided. In the same route back, the client will get the response. By using in this way, the client will get the response. So let's have a brief questions on it, which are possible. By using what we can able to create pods and services. By using what we can able to create and configure pods and services. This is important. By using what you are creating, you can create by using kubectl. By using what? kubectl. So to create cluster, to create this whole cluster, do I create public subnet? Yes, I need to create this public. So I need to create public subnet as well as private subnet. So to create this cluster, to create this data plane, do I need to create this private subnet? Yeah, of course I need to create. So for private subnet, where your private subnet will be present? Inside VPC only, right? Yes. So when I create my cluster, what I will need to create? What are the things that I need to create? I need to create a VPC, I need to create public subnet, I need to create private subnet, and I even need to create these things. What are the required things which are present under this? So when I create cluster, what are things I create? VPC, public and private subnets. Okay, what is pod? Pod is nothing but one or more containers, right? Yeah. Since one or more containers which are present on top of it, we call this as pod. So in simply, you can assume this pod as instance. So what is service? Sir, service is nothing but one or more pods. Okay. So what is node, sir? Node. What is the node? Node is nothing but it's a hardware unit where you can assume it as EC2 instance. These pods are present inside the nodes only. So why Kubernetes or kubectl is used? To provide communication between your cluster and Kubernetes, you use this kubectl. So where my servers and pods present in EKS, where my services and pods present in EKS inside my data plane, right? Yeah, you can able to track. So you can able to track and monitor whatever the resources which are present under these planes by using control plane, right? Yeah. So EKS will provide you a dashboard where you can able to monitor all these things. So there is one more important question. The important question is how containers, there are containers, right? They're having applications, right? Let's say if my application want to access S3 bucket, if my application want to access S3 bucket, how these containers will access the permission, how these containers will access the data which is present in S3? By using IAM role. So simply, so here you have two ways. One way is in order to access the data which is present in S3, this application need permission. Where this application present? In containers. Where these containers present? In pods. So what are these pods? Nothing but your instances, right? So simply provide an IAM role access to your S3 bucket to this pods. All the pods which are present, for those all the pods, you just need to provide attach the policy to them. So in that way, you can able to provide the access to S3 service data to this application. So what is the other way, sir? What is the another way? Another way is create your IAM role and attach your IAM role to EKS service account. So user service account is there in EKS Kubernetes development. So while developing your Kubernetes in the service account, you need to attach that IAM role. So in that way also you can able to provide your access to services, right? Yeah. So this is all about how the architecture of Kubernetes will be and how cloud overcome the issues faced by this architecture by using EKS service in AWS, and why we need this EKS Kubernetes to host containers, how many containers can able to host, what is rollbacking, how can we replicate, and how can we avoid downtime, how client can able to access the data. When do we use this EKS? We use this EKS for large scale applications. And how can I able to automate everything under EKS except my application data? By using EKS and AWS Fargate, you can able to automate and provide your robust application. What are the things which are present under my Kubernetes cluster, that is control plane and data plane? What are these control plane contains master nodes, data plane contains worker nodes. So where do we host our applications? We host our applications under containers which are present in data plane. Where do my applications will run? Either in master nodes or in worker nodes. My applications will run under my worker nodes. So where these worker nodes present, what these worker nodes contain, where my application containers present, my application containers present under pods. So what do we call in a pod? How many containers I have? One or more. So if I want to host larger applications, I need multiple containers, right? Is single pod sufficient to me? No, right? So I need multiple pods. How can I able to get those multiple pods? By using service, you can able to get multiple pods. By using what we can able to configure these pods and services inside data plane? By using kubectl. So whenever you create this whole thing, that is pods and services, so is the traffic allowed? So this service have DNS, right? So by using this DNS, can I able to access this from outside from the public internet? No, you cannot able to access. How can we able to access? You need to provide ingress rules and ingress controller to provide access to application load balancer. Your request first reaches to application load balancer, then it reaches to ingress inside your private subnet of your data plane. Then only it can reach to your application. In that way only you can reach to application. First it reaches to service, and it reaches to pods, then it reaches to container, then it reaches to application, then it got the response. So this is how the way, this is all about EKS service, and this is the whole concept which is behind your EKS. So I hope you got some knowledge from this video. So if you feel this video is contentful, then please like, share, subscribe, and hit the bell icon to get the latest updates. See you back in the next video. Until then, bye bye. Thanks for watching again.